Right, the last video on fourth video on topic 3.10 trig equations and inequalities. So this one focuses on inequalities, right? I will not be using this unit circle. I think I have a different way of approaching these questions, although I'm not saying that you cannot really do with this unit circle. But I mean, I'm not sure whether in the actual questions, in your exams or quizzes, you're going to get this unit circle. But anyway, what I prefer is I make uh, I make the I make the graph of the parent function as in sine theta from 0 to 2 pi, which by this time I hope you guys remember. If you don't, then please memorize these parent function graphs as soon as possible, because this unit is going to be easy for you if you remember these basic things. So this is 1, this is minus 1. Okay, I want less than negative 1 over 2. Now, negative 1 over 2 is obviously somewhere here, right? Negative 1 over 2 is probably somewhere here. This is the line of negative 1 over 2. And less than means obviously below the green one. So my solution will be this in 0 to 2 pi. Now, how will I find this? When is sine 1 over 2, by the way? I'm not interested in the negative one right now. I just want to find the reference angle. Sine is 1 over 2 at pi over 6. So that's where at least this unit circle could be helpful, although they have not really indicated the values. But yeah, at pi over 6, sine is 1 over 2. But sine is negative in quadrant 3 and 4, right? So it's quadrant 3 equivalent, which is obviously this. It's going to be pi plus pi over 6, which is 7 pi over 6. So this is 7 pi over 6. And the quadrant 4 angle will be 2 pi minus pi over 6, which is 11 pi over 6, which is right here, 11 pi over 6. Okay, so between this, I want my answer. So that's about it. And I don't want it to be equal to negative 1 over 2. So I will keep, I will not include equal to sign in my inequality. Just 7 pi over 6 to 11 pi over 6. That's the answer for this one. And that's how I'm going to approach all the questions of sine, cosine, and tan. Obviously, the only condition is it's not a big condition that you should memorize the graph of parent functions. Now we have cosine here, so I know that the graph of cosine looks like, well, this. So this is pi over 2, this is pi, this is 3 pi over 2, and this is 2 pi. When is cosine root, and by the way, I want it to be greater than negative root 2 over 2. So this minimum is negative 1, maximum is 1, and negative root 2 over 2 probably somewhere over here. So I want it to be above the blue line. So the answer is this and this. And equal to root 2, negative root 2 over 2 is also allowed, so it's fine. Now, when is cosine root 2 over 2? At pi over 4. But I want it to be negative, and it is negative in quadrant 2 and quadrant 3. So its quadrant 2 angle is going to be pi minus pi over 4, which is 3 pi over 4. And quadrant 3 angle will be pi plus pi over 4, which is 5 pi over 4. So this is 3 pi over 4. This is 5 pi over 4. So my answer will be in interval notation. It's going to be x is an element of, this is just an element of symbol. If you don't want to use it, it's totally fine. I can just write that 0 to 3 pi over 4. 0 is definitely a part of the answer, because at 0 it is 1, and 1 is definitely greater than this. 3 pi over 4 is also a solution. Union 5 pi over 4 is a solution, but 2 pi is not a solution because they are not including 2 pi. So this is where I'm going to end my answer with a parentheses. Okay. I want sine to be negative. That's what they say, that fx has to be less than equal to 0, which means that sine x should be less than equal to 0. It's pretty straightforward, right? Because sine is this. This is pi, 0, and 2 pi. Less than equal to 0 means obviously below the x-axis, which is something like that. So the answer is going to be pi included and 2 pi not, or 2 pi is also included because they are including 2 pi in their interval. So I will also make a bracket here. So that's my answer. They want fx to be less than gx. Okay, so fx is 3 minus 4 cosine of x to be less than gx. That is just 1. I'm going to subtract both sides with 3, so negative 4 cos x is less than negative 2. I'm going to divide both sides with negative 2. So remember, inequality sign switches whenever you divide by a negative, and negative 4 over negative 2, sorry, negative 2 over negative 4 is just 1 over 2. Once again, I'm going to do the same strategy. There you go. There is the graph, and this is pi over 2. This is pi. This is 3 pi over 2, and this is 2 pi over here. Cos is greater than 1 over 2, which means that 1 over 2 is somewhere over here. So this is 1 over 2. And if it is greater than, it means that we are looking for this and this, the portion that is above the red one. All right. Now, when is cos 1 over 2? Obviously, one is quadrant 1 angle, which is just pi over 3. And the other one is quadrant 4 angle, which is 2 pi minus pi over 3, right? 2 pi minus pi over 3, which is 5 pi over 3. It's in quadrant 4, correct? Okay. Right, so this over here is, I'm not going to write the angles, I'm letting a little shorten space here, but the answer is going to be 0. Is 0 included? I think yes, because obviously this is greater than 1 over 2. So 0 is a part of my answer. So I'm going to say that it's from 0 included to pi over 3. Pi over 3 is not included because this is a less than, or eventually this is a greater than inequality. So this is parentheses, union, parentheses open, 5 pi over 3, and then 2 pi. Shall I include 2 pi? Yes, I can, because they are also allowing that. So this is the final answer for this question. Okay. Hx should be less than equal to kx, so h of x is 2 sine x, and that should be less than equal to 1 plus 4 sine x. So I'm going to subtract 4 sine x both the sides, so 2 sine x minus 4 sine x is minus 2 sine x is less than equal to 1. Dividing both sides with negative 2, of course, inequality sign is going to switch, and this will become negative 1 over 2. So I'm going to make sine over here. This is the sine curve. Negative 1 over 2 is somewhere over here. Okay. And I want it to be greater than equal to negative 1 over 2. Greater than equal to negative 1 over 2 means that it is something like this. Right? It should be above the red one, in other words. All right. When is sine 1 over 2? I'm finding the reference angle. So sine is 1 over 2 in, I think, at pi over 6. And sine is negative 1 over 2 in quadrant 3 and quadrant 4. So the angle that I'm looking for is pi plus pi over 6, which is 7 pi over 6. And quadrant 4 is 2 pi minus pi over 6, which is 11 pi over 6. So this point is 7 pi over 6, and this point is 11 pi over 6. Okay, so the answer is going to be, can I include 0? Yes, I can definitely include 0 because it is above the red one. 0 to 7 pi over 6. Can I include 7 pi over 6? Yes, because equality sign is allowed here. I mean, it can be the red one as well, which is 7 pi over 6. So bracket union 11 pi over 6. And can I include 2 pi? Yes, because it is allowed over here. And obviously, the 2 pi as in this number is above the red one. So this is our final answer. Right here, it is less than 0. So less than 0 would mean that I'm going to use um, um, if the product of these two is negative, there are two possibilities. Either this is positive, this is negative, or this is negative, this is positive, because then only the product will be negative. Let's do both the cases one by one. Let's take 2 cos x minus 1 to be positive and 2 sine x, I mean it's theta actually, plus 1 to be negative. Okay. 2 cos theta. Okay, all right. Let's solve for the left one. So 2 cos theta should be greater than 1, which means that cos theta should be greater than 1 over 2. Okay. When is cos theta greater than 1 over 2? And by the way, let's simplify this as well. So this will be 2 sine theta is less than negative 1, and sine theta should be less than negative 1 over 2. Okay. If we graph the cosine curve, that's going to look something like this, and 1 over 2 is obviously somewhere over here. So I'm looking for quadrant 1, of course, because greater than 1 over 2 means quadrant 1 and quadrant 4 over here. These are my answers. Obviously, specific values are yet to be found, but I'm trying to see if I can eliminate some regions smartly. Uh, Sine curve looks like this. Negative 1 over 2 will be somewhere over here, and it should be less than negative 1 over 2 means this is the quadrant that I'm looking for. So obviously quadrant 1 is just not possible, right? How can a quadrant 1 be possible? Because both should be convinced, right? Both should be happy. This should also be positive and this should also be negative. But in this region, only cosine is happy. Sine is not happy, right? Sine is not having any solution. So probably there is an overlap in the right side. So let's figure out the angle now. This angle is going to be, obviously cos is 1 over 2 at pi over 3. So its quadrant 4 angle will be 2 pi minus pi over 3, which is 5 pi over 3. So this is 5 pi over 3. And sine is 1 over 2 at pi over 6. So its quadrant 3 angle will be pi plus pi over 6, which is 7 pi over 6. And the quadrant 4 angle will be 2 pi minus pi over 6, which is 11 pi over 6. Now we need to find an overlap, right? Okay. Let's do a number line because let's plot these things on a number line. So I'm gonna say that this is the number line over here. 5 pi over, obviously 7 pi over 6 is in quadrant 3, so that comes first. Then comes 5 pi over 3 because that is 600 degrees. And then comes 11 pi over 6, which is 330 degrees. And then comes 2 pi. So the cosine is happy when, obviously we ruled out the first area. So it's happy when 5 pi over, it happens from 5 pi over 3 not included and 2 pi included. And then this happens when the sine is happy when 7 pi over 6 not included to 11 pi over 6 not included. So obviously the overlapping region is this one when both are happy. So the answer from here is 5 pi over 3 to 11 pi over 6. But this is not done yet, right? Because that's just 1/2. Now the next part is when this is negative and this is positive. So it's gonna be the same work essentially. So this is cos theta less than 1 over 2 and sine theta greater than negative 1 over 2. I'm just gonna copy these this graphs over here. Obviously the shaded regions are going to change, but that's fine. We can take care of that. So this is going to change. This is going to be pi over 3. Now don't pay attention to the yellow one. We are going to pay attention to the red one because we need it to be less than 1 over 2 here and greater than negative 1. Basically everything but the yellow. All right, now how will the number line look? The number line is going to start from, I think, pi over 3. Then it will be 7 pi over 6 because that's in quadrant 2. 5 pi over 3. This is something that we did earlier. 11 pi over 6, and it will end at 2 pi, and it will start from 0. Let's keep the cosine happy first. Cosine is happy with the red one, so pi over 3 to 5 pi over 3. And sine is happy from 0. 0 is included, yes, to 7 pi over 6, which is not included. And then 11 pi over 6, which is not included, and 2 pi, which is included. So obviously this is the overlapping region, which is from pi over 3 to 7 pi over 6. So the final answer will be this plus that. So that's going to be pi over 3 to 7 pi over 6 union. And this is 5 pi over 3 to 11 pi over 6. So this was a little on the challenging side, took a lot of time, but yeah, this is what our answer is. Okay, in this one, okay, the product should be positive, which means that either both should be positive or both should be negative. Let's take the positive case. So, well, thankfully this is not that bad because sine is greater than or equal to 0 when, of course, this happens, right? Above the top wave. So 0 and pi are also allowed, so it's from 0 to pi. And then 2 cos theta minus root 2 should be greater than or equal to 0, which means that 2 cos theta should be greater than or equal to root 2, which means that cos theta should be greater than or equal to root 2 over 2. Okay, so this is how it looks. Root 2 over 2 is somewhere over here. And I want it to be above this. So it should be this portion, this and this. Okay. It is root 2 over 2 when it is pi over 4. It is also root 2 over 2 in quadrant 4, which is 2 pi minus pi over 4, which is 7 pi over 4. But I'm only interested, honestly, in the answers from 0 to pi because that's where the left one is, happy. So pi is obviously here, it ends here, so I'm not interested in this. This is the only region that overlaps with this one. So for this one, my answer is 0 is also allowed, and pi over 4 is also allowed because here there's an equal to sign. So this is at least from this half. For the other one, I need to have sine to be negative or less than or equal to 0, which means that obviously this is my answer, right? So it is from pi to 2 pi. And the next one should be, this sign will also change. So this will become cos less than or equal to root 2 over 2, which means that I'm looking for this as my answer, right? Less than root 2 over 2. So it is from pi over 4 to 7 pi over 4. Pi over 4 to 7 pi over 4. Okay, we are just looking for obviously pi onwards because that's where sine is happy. So this is the answer that I'm looking for. It should be from pi to, you understand, right? Otherwise I can make a number line. I can make a number line to indicate that. So this is pi over 4, this is pi, this is 7 pi over 4, and this is 2 pi. So this is going to be from pi over 4 to 7 pi over 4, and this is going to be from pi to 2 pi. So this is our answer from this one. So that's going to be from pi to 7 pi over 4. So answer is this as well as this. Right, here I'm going to take cos as a common factor. So cos theta minus 1 is less than 0. Now this is not the same thing because here I have cos and cos. If it is same trig function, then it's actually easier because I can just treat that one cosine as, well, x probably. So I'm going to solve x times x minus 1 is less than 0, which if you remember, that's a number line thing. We make a number line, we plot the zeros, so it's 0, it's 1. Then we put any number greater than 1 of our choice, which is obviously going to give us positive. And since these are all odd powers, it's going to toggle plus minus plus. So our answer will be, well, I want to be less than 0, which is here. So x should be between 0 and 1. And what is x? X is cos. So cos should be between 0 and 1. So I'm going to draw this cos over here. Cos should be greater than 0, which means that it should be here. And obviously it's maxed out anyway at 1, so I don't have to worry about that. This is pi over 2. This is 3 pi over 2. This is 0. And this is 2 pi. So the answer is going to be open interval 0 to pi over 2. Why open? Because at 0 it is 1, but 1 is not allowed. So 0 to 1 over 2 union. And why pi over 2 is not allowed? Because it is 0 and 0 is also not allowed. Union 3 pi over 2 to 2 pi. So that's going to be our final answer for this. Okay. Exact same approach over here. I'm going to take sine theta as a common factor. So I'm left with 2 sine theta minus 1 is greater than 0. Likewise, I'm going to replace sine theta with probably x, y, whatever you like. Let's call it y. So y times 2y minus 1 should be greater than 0. I make a number line here. This should be 0. This should be 1 over 2. Greater than 1 over 2, obviously positive, negative, positive should toggle. It should be positive, which means that either y is less than 0 or y is greater than 1 over 2. Y is sine, so sine theta should be negative or sine theta should be greater than 1 over 2. So sine is negative. When is sine negative? When, of course, this happens. It is below the x-axis. So it is between 0 and pi. Sorry, what am I saying? Pi and 2 pi. Pi and 2 pi both are not included because 0 is not included. So the first answer is pi to 2 pi. And when is sine greater than 1 over 2? When this is 1 over 2. So when this happens. All right. Okay. When is sine 1 over 2 at what angle? In quadrant 1, that angle is going to be pi over 6. And in quadrant 2, that angle is going to be pi minus pi over 6, which is 5 pi over 6. So, okay, it's difficult to write here, but 5 pi over 6. So the answer is going to be the green one, open interval, of course, pi over 6 to 5 pi over 6. So the answer is, of course, this one as well as this one. Both are the answers.